In problem 8.4, we are given a few scenarios dealing with filling two different sized pools up with water from hoses. Now specifically, we have a small pool, which they tell us is 15 inches deep, and we have a big pool, which they tell us is 27 inches deep. Besides having different heights, the pools also have different widths, so that's going to make them kind of fill up at slightly different speeds as well. Now, when we go ahead and graph these, they tell us that they want the height to be a function of time. So in other words, our output is going to be height, which means that's going to go on our y-axis, and our input is going to be time, and that's going to go on our x-axis. And we can see that down here on the graphs that they've already made for us as well. Now for sketching our graphs here, I'm going to use red for the small pool, and I'm going to use blue for the large pool. So in the first scenario, we are told that we're filling up both pools, and once the small pool fills up, we're going to turn that hose off, but keep the other one going, and then when the large pool fills up, we will turn that hose off as well. So we'll start with the big pool here, and we know that this pool is going to fill up at a constant rate, because they tell us that, until it is 27 inches deep. Now a constant rate means that this is going to be a straight line going up, starting with being empty, all the way until we get up to 27 inches. So we'll just draw on a straight line. It'll look something like this. When we get to 27 inches, now it's full, and it'll just kind of level off after that. Ooh, that's not very level. It'll level off after that. The small pool, because it's not as wide as the big pool, the height is going to fill up a little bit faster if we think about it. So this one will also fill at a constant rate, but that's going to be a slightly faster rate. And this one will be filled when we get to 15 inches of water, and then it will be level after that. So there are our two graphs representing our two different pools. In situation 2, we are now told that when the small pool gets full, we shut off both hoses. So let's draw our same graph for the small pool. Right, around like 5 minutes, we'll say it's full. So it's going to go up until it's full, and it's going to level off. But in this problem, we know that the large pool's hose also gets shut off at the same time. So it's going to do the same thing it did in the first problem, right? Start at 0. It's going to go up at this constant rate. But then when we get to right here, that's when the small pool gets shut off. But this time, we also shut off the large pool. So it's not going to be full. It's only going to have like 9 inches of water in it. In situation 3, right, one more, we have another twist in this, where once the small pool is full, we take its hose and put it into the large pool, so then the large pool will fill up faster. So the small pool actually looks the same again. Right, it goes up until we get to about 15 at constant rate, and then it levels off. But the large pool, what it's going to do is it's going to be filling up slowly until we get to here. Because right here, once the small pool is full, now we put the hose from the small pool into the big pool. So it's going to fill up faster until we get to 27 inches deep. And then it is going to also level off. So there's 3 different situations with 3 different graphs representing the height of the water as a function of time.